A very good morning to all. Welcome back. In this video, we are going to see about the open addressing. Before we proceed into open addressing concept, first we will have a quick look up on the hashing concept, hash function, and the collisions. Okay. The hashing is nothing but that is a mechanism which is used to map the large volume of data into a small table. Okay. For mapping it, we will use the hash function. Hash function is the mathematical equation which is used to compute or find out the location to store our value. Okay, that hash function, it is having a three types: division method, mid square, and the digit fold. We can adopt any one these functions to find out the place to store our value in the hash table. And the next one is the collision. While we are storing these values, some key values, it may produce the same index position or request the same index position. It is called as the collision. The collisions are avoided or find out the solution for this kind of collision is in two types: separate chaining and the open addressing. The separate chaining, it will use the linked list concept. It is used to store the values in the same index position by using the nodes. The next one is the open addressing. This open addressing, it is a mechanism. Again, it is having a three types to find out the solutions for the collisions. Okay. Here it will use the array instead of linked list. Already we have discussed, right? The separate chaining, it will use the linked list for implementation. But while we are coming to this open addressing, it will use the array concept to insert the values. Okay. Here we have to compute the index position in order to store the value. If the slot is being already unoccupied, then it will be stored. If it is occupied, then we have to find out the unoccupied slots to insert our new value. Okay. Here also we will use the hash function. This hash table, basically it will be used to search sequentially that starts from the original location of the hash. This is the equation which is used to find out the unoccupied positions in the hash table. Okay. Basically we will apply this first formula. If that, it will return the one index position. If that particular index position is occupied, then we will compute the next position by using the following equations. Okay. Next you can consider this example. In this example, we are going to insert the 5 key elements: 50, 70, 76, 85, 93. In this we have to use the key mod 5. That is, our table size is 5, then the key value. Okay. Here we are going to use the first method, that is called as the linear probing. Initially the hash table will be empty with a table size of 5, 0 to 4. Okay. For find out in the position, we have to use the hash function. First we have to do with the normal procedure. Okay, 50 by 5, 0, index position 0, we will store this 50. Then next value is 70. If we compute the index position, 70 modulo 5 equal to 0. The 0, it is already occupied, so we have to use the another formula, that is this formula. Okay, index equal to index plus 1 modulo hash table size. What is our index value is 70, right? 70 plus 1 modulo 5. So 71 modulo 5. So what will be the remainder? The remainder will be 1. So the 70, it will be get stored in the 1, index position 1. Okay. What will be the next value? The next value is 76. Okay. If you compute this, we will get the remainder as 1. So the 70 is already at the slot 1. So we have to compute the next position. So 76 plus 1 will be a 77. 77 divided by 5. So the remainder will be 2. So this value it will get stored in the 2. Okay. So the next value is 85. So 85 also it will return 0. So we have to compute 80 plus 1, 80, 85 plus 1, 86. So if we compute the 86, the remainder will be 1. So it is already occupied by 70. So next if you increment plus 2, it will return index position is 2. 2 also it is already occupied. So next plus 3. So 85 plus 3 is 88. 88 means it will return remainder as 3. So the 85 it will get stored in the index position 3. This is the reference book. Thank you.